Okay, example 4 asks us to identify the exact values needed to complete each ordered pair on the graph of the inverse trig function. First thing we want to do is figure out which inverse trig function we're looking at here, and recall that the sine parent graph starts here at the origin, and it goes up to its maximum, back to its zero, down to its minimum, and back to its zero. So that would be the sine parent graph. If I reflect that over the line y equals x, notice that I would get this shape. So this is the graph of y equals the arcsine of x. Now on the parent graph of the sine function, the maximum here is at 1. So this coordinate at the maximum is pi over 2, comma 1. Then here in the middle, this would be 0, so pi comma 0, and then 3 pi over 2, negative 1, 2 pi 0. But we're looking a little closer here. It's like we're zooming in on just this section of our sine curve. So we're looking for these values in between negative pi over 2 and positive pi over 2, and switching our x and y. So the sine of pi over 6 is, if you're using your left hand first quadrant trick, you bend your pointer finger, and the sine of pi over 6 is 1/2. So switching the x and y, I would get 1/2 pi over 6. Then root 3 over 2, that is occurring as the y coordinate when the x for sine is pi over 3. That's our ring finger in the first hand quadrant trick. So we switch the x and y, and we get root 3 over 2 pi over 3 on the inverse. Then here, be careful, students are tempted to say that this is pi over 4 that produces a negative root 2 over 2, but pi over 4 is just the reference angle, right, for the first quadrant. So since we're here in the negative x and negative y directions, this is quadrant 4, that makes this a negative pi over 4 as the y value. So that comes from the strategy of finding the corresponding points on the parent graph and switching the x and the y. Another strategy is to think of the ordered pairs as x comma arcsine of x, or if you think of that as the sine of y comma the y value, right? Then you're also going to get the same answers by evaluating the arcsine of root 3 over 2, right? That gets you your pi over 3 principal value. The sine of pi over 6 is 1/2, and then the arcsine of negative root 2 over 2 is negative pi over 4, and that's a principal value. So next, you're going to answer the secret question on some scratch paper and show all your work. You're going to upload this as the last page of your notes to Schoology, and then enter your answers in the assignment in Schoology. So make sure that when you're solving this equation, you're working in radians, that you're rounding to 2 decimal places, and notice that this is asking you to find all of the approximate values, not just the values in 1 revolution 0 to 2 pi, but all of the approximate values. So you're going to need to write expressions that represent those solutions.